kind of have to pay a little bit of attention to this. Inequality, by the way, what is an inequality? I guess we should not proceed unless you know what an inequality is. Somebody, inequality. The name Grace Watson is self-explanatory. What is an inequality, or give me an example of an inequality? Something that is not equal, yes. And how do we usually see inequalities? Nobody. Feel it. It's kind of early in the day. Alex?
Example, I think it's linear, the square root of 2.
I think you're thinking of irrational numbers there. Somebody, anybody? We have inequality signs. They are greater than, less than. You could have greater than or equal to, less than or equal to. In other words, this. Let me give you an example here. 5x is greater than 30. That's an inequality. But you're asked to solve that inequality for the letter x, and it's done just like an equation. If you were to put equal signs there, let me do it in the shade of yellow. What would you do to solve this for the letter x? You would, Ryan, divide by 5, right? Divide by 5. So x is greater than 6, correct? And then a lot of times we were asked to graph it. You would put a 6 down there. You put an open circle there because it's not equal to, and it goes that way. Okay. Except, we have to put an exception here. Solve the same as equations, except, put this in big letters here because this is a big difference. Except, okay, in your answer, well, except the variable must, M-U-S-T, end up on the left. And here's another big one. The variable must be positive. And that's really true with any equation, but we have to specifically look at those, and I'll let you write them down, and then we have to talk. Can we talk? We have to look at the fix for this sort of thing. For example, this. If you have this, 6 is greater than x. This is unacceptable. In your answer with inequalities, the x must be on the left-hand side. It just prevents all sorts of confusion there. You know, with an equation, it didn't matter. If you had 6 equals x, it doesn't matter because x equals 6 and 6 equals x. It doesn't matter. They all get messed up. But this, you have to be careful with. Okay? Look at Mr. Alligator. Let's go back to the alligator scenario here. Which one is the alligator eating? 6. So the 6 is bigger than the x. So when I change this into the form that I need, the x needs to go on the left side. Okay? The 6 needs to go on that right side. And the alligator still is eating the bigger thing, and that doesn't change just because you flip-flop things. So this, when you flip-flop x from one side to the other side and a number to the other side, the sign has to change as well. Okay? The alligator is still going to eat the bigger number, which doesn't change just because you move it from one side to the other. Okay? So if you end up with, you know, in the end, you end up with, you know, 30 being less than x. Okay? If you wrote that down on your paper, it would be wrong. But it's an easy fix, and that you just, I like to say, you think about there being like a little axis of symmetry there, and it flip-flops. The x goes here, the 30 goes there, but that sign also gets changed. X is greater than 30 because the alligator. The other thing is this. When your letter is negative, negative x is greater than 15, this is also not acceptable. Your variable can't be negative in your answer. Okay? And the fix for that is really this kind of the same thing. You can change this to positive, but everything else has to change to its opposite as well. 15 is going to become its opposite, and the sign is going to become its opposite. Which I should probably write this down. Write this in big letters in your notes there. Anytime you multiply or divide both sides by a negative, your sign becomes the opposite. I can't stress that too much. And we'll do some examples, but a lot of you will continue to get them wrong just because I don't know why. Are you ready? Yes. Please listen carefully. Here's an example. Negative 3x minus 10 is greater than 8. Negative 3x minus 10 is greater than 8. Take a deep breath. Inhale. Hold it. Exhale slowly. Okay, here's the deal. If I were solving this, if this had an equal sign here, what's the first thing I would do? Ryan? Pretend this is an equal sign and I want to solve it for x. First thing I would do is add 10. That does not change. I'm going to add 10. Now notice I am not multiplying or dividing. This sign does not change because I add 10 to both sides. It stays exactly the same. Okay? I end up with now a negative 3x, it's still there, is greater than 18. The sign did not change. I can add and subtract all I want. This sign will not change. It's only when I multiply or divide by a negative. Okay? Now, in order to get the x by itself, what do I need to get rid of? This negative 3. Okay? And you can do it in 2 steps or do it in 1 step if you want. You could divide by just a normal 3 if you want first. Okay, I didn't divide by a negative, but I end up still with a negative x is greater than 6. And then at this point you can say I can't have that as negative, so I have to go opposite, 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 which makes it x is less than negative 6. Or, at this point here, you could have done that in both in 1 step and said, okay, I need to divide by a negative 3 to get rid of the negative 3. I divided by a negative, so that's going to change the sign. I divide both sides by a negative. It ends up being that. Either way you do it is fine, whatever way works for you, but anytime you multiply or divide by a negative, this sign is going to change. I know you want to see another one. Oh, let's get a little more complicated. Negative 5 times x minus 3 is greater than 5 times x minus 3. Is that right? Sure. If you saw this, the first thing you would do here is distributive property. Signs aren't changing because I'm not doing stuff to both sides. I'm just simplifying it here. What do I get if I multiply this negative 5 times both of those? Negative 5x plus 15, correct? What do I get if I multiply the positive 5 here? 5x minus 15, correct? Okay, now I need to start moving things over by adding and subtracting, and the sign will not change when you add or subtract something. It has to be multiplying or dividing. So what am I going to do? Let's just do this. Because my x's need to be on the left side, I'm going to move this to the left side. I subtract 5x. What is a negative 5x minus 5x? Anybody? Maggie? Negative 10x, right? Plus 15 is greater than negative 15. Next thing I would do would be to do what, Caleb? If this was an equation, what would I do? Subtract 15. Again, the sign doesn't change because I'm adding and subtracting, not multiplying. This becomes a negative 30. Now I have a negative 10x is greater than negative 30. I am then going to do what? It's not a ghost, children. No, it's not. Somebody, here we go. I gotta get x by itself, so I am going to, Cameron? Nope, not add. Because this is multiplication. Negative 10 times x. I can't add it. I already did my adding and subtracting up there. Divide by? What's that? Okay, you're just going to divide by a normal 10. If you divide by a normal 10, the sign will not change. You'll end up with a negative x is greater than negative 3. And then the last thing you're going to have to do is change them all to their opposites. This needs to be positive. Positive, less than, positive. It's like you're multiplying or dividing by a negative 1. So you're going to end up with positive x, opposite sign, positive 3. And graphing it, it would look just like that. I can tell you want to try one here. Sure, why not? Let's try this one. Negative 7x plus 2. Negative 7x plus 2 equals 8x plus 4. Let's see, no, is is less than or equal to 8x plus 4. See if you can't get me the answer for that. Will you try that with, please? Negative, do it like it's three-dimensional. See if you can't get me the answer and graph it. The directions say solve and graph. Negative 7x plus 2 is less than or equal to 8x plus 4. Solve and graph. You should be supposed to be a number. We get an answer? Somewhere out there, please. Nobody's brave enough to venture out. David Swenson, what'd you get for an answer? Yeah. Huh? 3. You can't say 3 because there's inequality signs in there. X is less than, equal to, greater than, less than what?
X is less than equal to when x plus 2.
What? Anybody get Shellhammer? X is
X is
less than or equal to 17. That's what you got? Good. Maggie?
X is less than or is greater than equal to 1.
0.103?
0.1
Well, let's see. Kayleen, what's the first thing you did?
added 7x.
To both sides? Okay, I'll go with that. Sure, you can do that. I'll add 7x to both sides. That leaves me, this goes away. Leaves me with 2 is less than or equal to 15x plus 4, right? I added 7x to both sides. Well, we can do it that way. Again, I'm looking to solve for x, so the next thing then I would have to do is what, Caleb? Did I write the problem down wrong? Oh, probably. Maybe that's why you're all going wrong. I don't know where this negative came from. Let's just pretend I wrote it down right. Let's redo it again. I'll give you a second chance at it because you wrote it down wrong. Let me change this to a positive. Try it again. See if this makes sense. You would have gotten a fraction. Maybe you were right. I don't want to get a fraction. That's just the way it sounds. I don't know how that happens. You get a different answer? Ryan, did you get an answer this time?
No.
Somebody get an answer this time. Landon?
X is less than or equal to 3.
X is less than or equal to 3. All right, let's see what happens. What did you do first?
Subtracted 7 from both sides.
7, subtracted 7 from both sides, 7x, right? Which is fine. So now you have 2 is less than or equal to 1x plus 4. Right?
And then
Not sure where a 3 would come from out of this, but then you did what?
subtracted.
What would you do if you were here, Noah? Let's work with this one. If you saw this, what would you do next? I want to get x by itself. You done? I want to get x by itself, so I have to get rid of this, which is subtracting 4. 2 minus 4 is negative 2. Alright. This, children, is close to right, but it's not acceptable because you're not allowed to have the x on that side. It has to be on the left side. So I can change them, but the gist is when I change them, the sign changes as well. If alligator's eating the x, it stays eating the x. You flip sides, and signs get changed like that. Did anybody have that? Winner, winner, chicken dinner. One more, because I can sense we're making somewhat slow yet unanimous progress. How about this one? Let's try this. Negative 5x, I'm going to write this one down right, plus 25 is greater than 5 times x minus 5. Once again, I will give you 45 seconds to get that. Maybe 50. You want x by itself on the left side and positive. X by itself, left side and positive. This is no more complicated than equations. I'm not sure why. Let's look at it here. You got some answer somewhere. First thing you would do is the distributive property with this 5. 5x minus 25. Everybody do that first? Please say yes.
Yes.
Alright, now here's where you have to make a decision. You're either going to move your 5x over here or your 5x over there. If you're 25, you got to go opposite sides. Which way did you go, David? This one? Wait, you subtracted this one? Alright. What do you get when you take 25 minus 25? Negative 50. Notice the sign doesn't change because we're not doing multiplication or division. It's the only time the sign changes when it's positive or negative. Now what would you have to do? I got my numbers over there, so I'm really left with no choice, but I need to get this 5x over here, so I subtract 5x. Again, the sign doesn't change because we're adding and subtracting, now multiplying. That gives me a negative 10x is greater than negative 50. How many people got that far? Now what do we have to do? This is the part where the multiplying and dividing comes from. You need to get x by itself, so you need to get rid of this negative 10. Sorry. Divide by negative 10. Divide by negative 10. This sign is going to change because you divided by a negative. Negative 10 divided by negative 10 is just an x. Negative 50 divided by negative 10 is a 5. And the graph of that is 5, open circle. I don't want to ask, but how many people actually got that? I do want to ask. As long as